It's assembly time. Mounting the switchboards to the bus bars and caps will take a bit, as I haven't drilled any of the mounting holes for the boards yet. I wasn't quite sure how much flexibility I would have on the thin bars soldered to the MOSFET boards. I'm just positioning the board where I want it and marking it. This first board will set the spacing for everything else. The bar to the capacitor will get a close-fit clearance hole for the 5mm screw. There's not a lot of surface area on the capacitor terminal. The bus bar and the board connection to it will get a 1/4" clearance hole. 2 switchboards will be connected to the bus bar with a 6mm screw, the same way the positive capacitor bars are connected. I'm going to mount a couple of 175 amp Schottky diodes across the bus bars. They are in the power tab case, so I can just drill and tap a couple of small holes and mount them directly to the bus bars. I've tested with 2 of these diodes with 3 capacitors, and it has worked, but now with 6 capacitors, more copper bus length, and lower on-switch resistance, I may have to move to bigger diodes. A logic level to 12-volt signal level distribution board will feed the timing pulses to the switchboards. Right now I'm running a separate line to each module. I hope later I can do board-to-board connection, but for right now I want to start testing this way. So I'm going to need 6 wire harnesses. They are all going to be 15 inches in length, as they are starting off with a common ground. I will see what kind of trouble that causes. For the connectors, the PC board pin spacing is 0.1 inch, so I'm using a cheap PC board header and wire housing kit from Amazon. They really seem to be pretty good. The capacitor's negative terminal will connect to the ground block through a 7.5 inch 12-gauge wire, about 1 milliohm. I'm going to start with this and see where the testing leads. The ground block is just made from some copper bar. I only had a small piece of 3/8 inch scrap, so it's 1 inch wide and 3.5 inches long. I drilled through holes that would be big enough to hold 10-gauge wire. I'm going to use 832 screws to clamp the wire in place, so I have to drill and tap 2 holes for each of the through holes. It should make a pretty good low resistance grounding block. After drilling all the mounting holes, it's time to put everything together. I'm trying to keep the aluminum connections on the capacitors from oxidizing by keeping a good layer of antioxidant on it, even making sure there is a good coat of it on the fine sandpaper. I'm installing the modules with the long connecting arms first, as the short connecting arms will bolt on top of the long ones. I'm just going to hand tighten the screws for now to lightly hold the modules in place. Now as I get the last module in place, it's time to line up the thin connecting bars and bolt them down. Once they are all in place, I will torque them to 13 Newton meters. Installing a plastic separator. Sure don't want the ground block too short to anything. Then finally hook up the signal wires, and then it will be test time. Thank you for watching.